The universe is talking to us, not in words but in light. Every star, every galaxy, every glowing nebula, we've built incredible tools, telescopes that can peer back to the dawn of time. To read this story, we've learned about the birth of stars, the violent deaths of supernovae, the silent gravitational pull of black holes. We think we have a pretty good handle on the major plot points, but what if some of the most intriguing parts of this story are written in an ink we can't yet decipher? What if some lights in the sky have no author we can identify? These are the universe's ghost lights. They flicker into existence where nothing should be. They shine with an intensity that defies our models. They disappear without a trace. It's a profound and humbling reminder that the cosmos is still the ultimate frontier. We are cosmic detectives. These unexplained lights are our most compelling cold cases. They force us to ask bigger, bolder questions. Are our theories of physics incomplete? Is there a type of matter or energy we have yet to imagine? It's a scientific mystery of the highest order. Imagine pointing the Hubble Space Telescope at empty intergalactic space. You expect darkness, perhaps the faint glimmer of a distant galaxy. Instead, a brilliant point of light flares up, brighter than an entire galaxy, and then vanishes. This isn't science fiction. Fast radio bursts, other transient luminous events are real. They are recorded, they are cataloged, debated furiously by scientists around the world. Each one is a puzzle piece from a picture we don't yet have the box for. The beauty of science is that it thrives on ignorance. It's the things we don't know that propel us forward. These ghost lights aren't a failure of our understanding. They are an invitation. They are the universe beckoning us to look closer, think harder, dream bigger. They represent the edge of our knowledge, the thrilling boundary between the known and the unknown. Every time we spot one of these phantoms, we are reminded we are still beginners in unraveling the grand cosmic narrative. The show is just getting started. The universe has saved some of its best tricks for last. Let's journey to one of the loneliest places in the universe, the vast, cold, dark space between the galaxies. This is the intergalactic medium. For the most part, it's an empty void, a near-perfect vacuum stretching for millions of light-years. You wouldn't expect to find much happening here. A few stray hydrogen atoms, some dark matter, a whole lot of nothing. So imagine the shock when astronomers detected an incredibly bright flash of light originating from this cosmic no-man's land. There was no galaxy, no star cluster, no nebula nearby, just a brilliant orphan light that flared and faded. This is the strange case of the orphan transients. Supernovae gamma-ray bursts require a host. They need a galaxy to be born in. Stars, after all, live in galaxies. Like finding a bonfire in the middle of the ocean with no boat in sight. It forces us to reconsider what's possible. Perhaps there are rogue stars, flung out of their home galaxies by gravitational encounters and exploding in solitude. Or perhaps it's something else entirely. Another chilling location for these ghost lights is near the most extreme objects in the cosmos, supermassive black holes. When confronted with a mystery as profound as ghost lights, scientists are forced to get creative. We start with the known possibilities and work our way to the truly exotic. One conventional wild theory, a completely new type of stellar explosion. We know about Type Ia Type II supernovae, but what if there are Type 3, Type 4, Type V? Perhaps stars so massive or with strange chemical composition when they die, they don't go out with a bang we recognize. They might produce a unique light signature, a new class of object. Then we move into even stranger territory. What if these lights aren't from stars at all but from planets? Not just any planets, Chthonian planets. Once a gas giant like Jupiter orbiting extremely close to its star. The star's intense radiation strips the atmosphere, leaving a dense, rocky core. If such an object were to collide with another body or fall into its star, it could produce a bright flash unlike typical stellar events. It's a long shot, but you can't rule out long shots in the cosmos. Let's push the envelope further. So, to really appreciate just how strange these ghost lights are, you need to understand what normal looks like in space. Most of the lights we see in the night sky are stars, and they're incredibly stable. Our own sun has been shining with remarkable consistency for about 4.5 billion years. Some stars, called variable stars, do change in brightness, but in predictable, repeating cycles. A Cepheid variable pulses with such a reliable rhythm astronomers use it to measure distances. These are the known quantities, the steady heartbeats of the cosmos. But ghost lights? They're the cosmic arrhythmia. They don't have a predictable rhythm. Sometimes one-off events, sometimes appearing and disappearing on odd timescales. A typical supernova brightens over weeks and fades over months. LF Boötes, luminous fast blue optical transients, can peak in days and vanish almost as quickly. Their light curves, graphs of brightness over time, are unlike anything we've seen. Too fast, too bright, way too blue. Now the spectrum of light is another really important clue. The cosmic mystery deepens. Some of these ghost lights don't just sit still, they move. Now in astronomy, movement can be tricky. Most objects are so far away, even if they're traveling thousands of km per second, they appear fixed in our sky. But we can detect motion in other ways. One is by measuring a Doppler shift in the light's spectrum, blue shift, moving toward us, red shift, moving away. Some transients show enormous Doppler shifts born from an event of incredible violence, flinging material at a significant fraction of the speed of light. But there's an even more direct kind of movement. Some radio transients change position in the sky over months. This is called apparent superluminal motion. It doesn't mean they're breaking the speed of light, it's an optical illusion caused when a jet is shot out nearly at light speed and aimed almost directly at us. Observing this from an unknown source is startling. It implies a compact, powerful engine capable of creating a relativistic jet like a quasar, like a microquasar, but where one isn't supposed to be. These ghost lights don't exist in a vacuum. Well, some of them literally do, but their implications are deeply connected to the biggest questions in cosmology. Consider the cosmic web. This is the large-scale structure of the universe, a vast, intricate network of filaments made of galaxies and dark matter, surrounding immense, empty voids. Understanding how this structure formed is a central goal of modern cosmology. The ghost lights, especially the orphan transients found in the voids, could provide a crucial new perspective. They might be tracing populations of objects we didn't know existed, like rogue stars or primordial black holes that wander these empty spaces. The study of these lights is also intrinsically linked to the mystery of dark matter and dark energy. Dark matter provides the gravitational scaffolding for the cosmic web, while dark energy is the mysterious force causing the expansion of the universe to accelerate. We can't see either of them directly, we only infer their existence from their effects on the things we can see. What if some of these unexplained flashes are the result of dark matter interactions? Some theories propose that if dark matter particles can annihilate, they might produce a flash of gamma rays or other light, a potential signature we could detect as a transient event. So we stand at the edge of a great cosmic ocean, and we see strange lights flashing in the deep. What are we truly seeing? We've explored the theories, rogue stars, alien lighthouses, but the most exciting answer, from a scientific perspective, is that we might be seeing the first hints of something for which we don't even have a name yet. Every major leap in astronomy has come when we've pointed a new instrument at the sky and seen something that made no sense. Galileo saw moons orbiting Jupiter, proving not everything revolved around the Earth. Hubble saw that distant galaxies were flying away from us, leading to the Big Bang Theory. These ghost lights could be our generation's moons of Jupiter. They could be the cracks in our current understanding of the cosmos, through which the light of a new, more complete theory will eventually shine. Perhaps they will lead us to a new understanding of the life cycle of stars. Perhaps they will reveal a new kind of compact object, or a new fundamental force of nature. The possibilities are as vast as the universe itself, and that is what makes this field of study so thrilling. It's a journey into the unknown in the purest sense. I invite you to let your imagination wander. Look up at the night sky. Between the familiar constellations and the steady glow of the Milky Way, untold mysteries are unfolding. Flashes of light, brighter than a billion suns, are appearing and disappearing in the blink of an eye, billions of light years away. The truth is, we don't know, and that is the most beautiful sentence in science.